velocity and acceleration analysis of mechanism by using relative velocity and relative acceleration method. First of all, we have to draw configuration diagram. The sketch for the configuration diagram is given in problem. Just we have to copy it. After completing configuration diagram, the next step is to draw velocity diagram. Before drawing velocity diagram, at least we should know velocity of one link. That's why let us find velocity of link OM. The velocity of link OM is VMO, that is M with respect to O is equal to omega of this link, input link OM, into link length, that is R omega. Link length is nothing but R, radius, omega into MO. Omega value is 4 radian per second, therefore 4 into MO value is 25 mm, therefore it is equal to 100 mm per second. Mm per second. Now by choosing some proper scale, let us draw velocity diagram. I am taking some suitable scale for drawing velocity diagram. See, for 1 centimeter we shall take 1 centimeter is equal to 10 mm per second. Such that for representing this value in velocity diagram, VMO, that is 100 mm per second, it will be as per scale 100 divided by 10, it will be 10 centimeter. First of all, take all the fixed point at one point, which is we can call the pole of velocity diagram. There are two fixed points O and T. Therefore, pole of this diagram is O, T. Small letters should be used. Now let us represent this velocity of link MO in this velocity diagram. As we know, velocity of the link is perpendicular to the link. Therefore, draw a line perpendicular to this MO link. This point is M. This vector represents velocity of m with respect to O. Now to get this point n, the corresponding point in velocity diagram, n, the direction of velocity of this mn and nt are known, which are perpendicular to these links, but magnitude is not known. Just by drawing perpendicular lines to mn and nt, we will get the third point n in the velocity diagram. First we shall draw the line perpendicular to link mn. Its direction is known, but magnitude is not known. Along this line we will get VNM. Now let us draw the direction of velocity for link nt perpendicular to this link nt. See this direction, this point is n and this is v and t, that is velocity of link nt. Of course all these are relative velocities. Now we are asked to find velocity of two links. The velocity of one link is given and we are supposed to find velocity of other two links, that is mn and nt. Let's find velocity of link mn. For that we need to find velocity of link nm is equal to link length nm, that is r, into velocity. But r value, r is nothing but link length nm into omega nm. Therefore omega nm is equal to vnm upon link length nm. Vnm can be calculated just by measuring this length nm. It is coming 6.4 centimeter. 6.4 centimeter into scale value. Scale is 1 centimeter is equal to 10 mm per second for velocity diagram, into 10 upon link length nm is 48 mm is equal to 1.33 radian per second. That is, here omega nm we got 1.33 radian per second. Similarly, we can find angular velocity for link nt. To find angular velocity of link nt, first find vnt upon link length, that is radius, which is equal to 30 mm. Measure nt distance from velocity diagram. It is coming 9.8 centimeter multiplied by scale, that is 10 divided by 30, which is equal to 3.26 radian per second. After finding angular velocities of all the links, now draw the table for the calculation of acceleration diagram. The first column is link, second column is link length, which is nothing but r, radius of rotation. Third column is velocity in mm per second from velocity diagram. Fourth column is centripetal component of acceleration for link, mm per second square. And last column is ft, it is tangential component of acceleration is equal to r alpha. Alpha is a angular acceleration and length of link is nothing but r. Unit is mm per second square. For link MO, length is 25 mm and velocity we have calculated from the given angular velocity of input link. It is 100 mm per second. Now FC, centripetal component of acceleration for link MO, is equal to V square upon R, that is link length. It will come 400. And FT value for link MO is equal to R alpha. R is nothing but link length. Alpha is angular acceleration. Angular acceleration for MO link, it is given in problem 12 radian per second square. That is Ft value is equal to 12 into 25 equal to 300 mm per second square. Similarly, we can find the centripetal and tangential components of acceleration for link NM and NT by referring velocity diagram. For link NM, the length is 48 mm and velocity, it can be seen from the omega nm formula, Vnm by nm. The numerator value, that is 6.4 into 10 is equal to 64, is the velocity value for link nm. Centripetal component of acceleration for link nm is equal to v square by r, that is link length. After calculation it will come 85.33. Now a tangential component of acceleration, we don't have value of magnitude of this component, but we have direction of this component which is perpendicular to link NM. Now for link NT, the length is 30 mm and velocity can be seen from omega NT formula, that is VNT by NT. The numerator VNT 9.8 into 10 equal to 98. Now centripetal component of acceleration for link NT is equal to V square by R. R is nothing but link length, that is 98 square upon link length is 30. It will come 320.13 mm per second square. The tangential component of acceleration magnitude, right now we don't have it, but we know the direction which is perpendicular to link NT. After these calculations, now select proper scale for acceleration diagram. Now let us take a scale as 1 centimeter is equal to 50 mm per second square. Then mark one fixed point. Then at that point take 2 points O and T for fixed links. After that set drafter parallel to link MO. And draw line through O with length equal to 400 upon scale, that is 8 centimeter. This will indicate the centripetal component of link MO. The direction of FCMO is from O to M as it is centripetal component. Then draw a line perpendicular to MO which will indicate tangential component of acceleration. Its value is 300 upon scale, that is 50, is equal to 6 centimeter. This indicates FTMO, tangential component of acceleration for link MO, which will give point M. Then join this point M with O, which will give resultant acceleration, that is FMO. Then draw a line parallel to link NM through M, which will indicate centripetal component of link NM. its value is equal to 85.33 upon scale, that is 50, is equal to 1.7 centimeter FCNM. Then draw line perpendicular to link NM. Here magnitude is not known, but direction is known, that is perpendicular to link NM. Along this line we will get the value of tangential component of acceleration for link NM. FTNM. Then draw line parallel to NT for FCNT through T of length equal to 320.13 upon 50, that is 6.4 centimeter. Which will indicate the centripetal component of acceleration. It is acting from N to T, that is towards center T. We get N double dash point. Then through N double dash draw a line perpendicular to NT, which will indicate the tangential component of acceleration for link NT. In this way we get point N. Join M with N, which will give the resultant acceleration for link MN. And join T with N, which will give resultant acceleration for link NT. We are asked to find the resultant acceleration for link NM. For that, measure this length NM from acceleration diagram, which is coming 4.4 into scale 50, which is equal to 220 mm per second square. This is all about velocity and acceleration analysis using relative velocity and acceleration method. Thank you.